Boeing is crashing and burning, both in the skies and on their balance sheets. More than $32 billion has gone down the drain since 2019. And right when the aviation giant is stumbling, Elon Musk casually drops a bombshell that sounds straight out of science fiction. He said, "I've got an entire design for an electric supersonic vertical takeoff jet." But then he added with that classic Musk grin, "Of course, since it's a totally new product, with totally new everything, it's like starting from zero." And here's the kicker, he didn't stop there. Musk threw in the number 10,000 electric aircraft. Let that sink in. While Boeing is struggling to keep their planes in the sky, Musk is talking about thousands of electric aircraft flying across the globe. That's not confidence, that's a declaration of war on the entire aviation industry. So, what gave Musk the confidence to push Tesla into the skies? And what exactly is the 2026 Tesla super electric plane that's now officially preparing to shock the aviation world? Today, we're diving into all of it. How Tesla managed to achieve a jaw-dropping 1,500-mile flight range in a compact VTOL design while somehow clearing the impossible walls of strict FAA regulations. These are breakthroughs nobody thought were even possible, yet they're happening right now. Police car light. Before we go deeper, smash that subscribe button and join over 189,795 dreamers chasing the next big thing. Don't miss a single spark, because what I'm about to show you could change how you think about flying forever. Now, let's get to the science and secrets that make this story so electrifying. One of the biggest questions is this: how could a simple lightweight metal like aluminum possibly end China's battery empire? Short wings that shouldn't fly far, yet Tesla's electric plane zips 1,500 miles, literally defying physics and leaving Boeing's massive designs in the dust. How is this even possible? Let's break it down. Here's where it gets absolutely mind-blowing. The Breguet range equation has been aviation's holy grail for decades. It's basically the formula that explains how far a plane can fly. For traditional jets, the equation depends on four major factors: velocity, fuel consumption, lift-to-drag ratio, and the weight difference between when the plane takes off full of fuel versus when it lands almost empty. For example, a Boeing 737 usually has a lift-to-drag ratio of around 17:1. Its engines burn fuel at about 0.5 to 0.7 pounds per pound of thrust every hour, and during flight it sheds almost 50,000 pounds of fuel. That's how traditional planes squeeze out their range. But Tesla completely rewrites this formula because batteries don't burn away like jet fuel. While Boeing is shedding weight in mid-air, Tesla's aircraft keeps nearly constant mass throughout the entire flight. That means the logarithmic part of the Breguet equation, which is usually a challenge for jets, suddenly works in Tesla's favor. Instead of fighting physics, Musk's team flipped it. With 95% motor efficiency compared to just 40% in traditional jet engines, Tesla's specific energy consumption drops to just 0.15 to 0.2 pound equivalent per pound per hour. That's a massive leap. But the real shocker? Tesla's targeting a lift-to-drag ratio of 25:1, way higher than the 17:1 of typical jets. That's a 47% improvement, and it feeds directly into the equation to add hundreds of extra miles in range. Now, let's talk wings. This is where Tesla pulls off its genius trick. At first glance, Tesla's 50-foot wingspan looks like a toy compared to Boeing's giant 93-foot 737 wings. But looks are deceiving. Tesla uses distributed electric propulsion with 8 to 12 small motors placed along the wing. Engineers call this the blown wing effect. Basically, airflow from the motor supercharges lift. Wind tunnel tests prove this setup increases lift by 50% while cutting drag by 25%. Suddenly, Tesla's compact wings act like they're twice their size. And they didn't stop there. By building the wings out of advanced carbon fiber composites, Tesla slashed the weight from 1,000 pounds down to just 600 pounds without sacrificing strength. This lets them achieve an effective aspect ratio of 10:1, making the wings feel aerodynamically much longer than they actually are. All of this adds up to that magic 25:1 lift-to-drag ratio, the sweet spot that unlocks the 1,500-mile range. But wait, it gets crazier. Tesla is experimenting with variable geometry technology, wings that can literally adjust shape mid-flight. During cruise, they retract props and shift into a streamlined form that reduces drag by 38%. Simulations show this design drops the drag coefficient to just 0.25, compared to Boeing's 0.3. That alone extends range by another 20 to 30%. The numbers don't lie. This compact Tesla jet can fly 1,500 miles on less energy than a Boeing 737 burns in just 500 miles. We're talking 20,000 pounds fuel equivalent for Tesla versus 50,000 pounds for traditional jets. And the environmental impact? Staggering. These wings, engines, and designs could slash 500 million tons of CO2 emissions every year, while delivering the range and endurance of a traditional jet with the agility of vertical takeoff and landing. This is Tesla's master plan to end Boeing's dominance in the skies. Every simulation, every test, every calculation screams the same conclusion: the aviation industry is about to be transformed forever. Now here's my question for you. Imagine traveling 1,500 miles in an electric aircraft that can take off practically from your backyard. Where would you go first? Drop your dream destination in the comments and let's see which city comes out on top. Because make no mistake, this distance opens doors that we couldn't even imagine just a decade ago. Now that we've unlocked the secret behind Tesla's incredible 1,500-mile range, let's dive into the next big question. How can Tesla overcome the FAA's strict pilot rules and actually make this plane a reality by 2026? Most people don't realize how tough aviation regulations are. The FAA doesn't play games, they are the ultimate guardians of passenger safety in the skies. Under 14 CFR Part 135, every single commercial flight must have a certified human pilot with at least 1,500 hours of training. Why so strict? Because when something goes wrong at 30,000 feet, it goes catastrophically wrong. That's why the FAA demands a catastrophic failure rate of no more than 1 in 10 million flights. This zero tolerance for death rule is exactly why Boeing's 737 MAX was grounded after 2 crashes killed 346 people. These aren't just rules, they're shields to protect every passenger's life. But here's where Tesla shows true genius. Instead of fighting the FAA head-on, they're outsmarting the system. Tesla starts under Part 91 Experimental Classification, basically the learner's permit of aviation. It allows them to fly test models, gather real-world data, and prove safety without being crushed by full commercial regulations right away. And the timing couldn't be better. The FAA is already showing more flexibility toward new electric aircraft. Just look at Joby Aviation, which is on track for certification by 2025. Tesla could use the same accelerated path and cut approval times in half, from the usual 5 to 10 years down to just 2 to 3 years. Tesla's secret weapon? Data. Mountains and mountains of data. They're showing the FAA terabytes of safety information from simulations plus over 10 billion miles of autopilot driving on the ground. Their AI error rate? Just 1 in 1 billion operations. Compare that to human pilots with a 1 in 100,000 error rate, according to FAA human factor studies. Tesla's message is simple. Our AI doesn't get tired, doesn't get distracted, and doesn't make emotional mistakes. It just works. But they're not going fully rogue with automation. Tesla's strategy is a hybrid model. The AI handles primary flying, but remote human pilots monitor everything using Starlink satellites with under 100 milliseconds of latency. That means there's always a human safety net. Think of it like Uber for the skies, but safer. And redundancy? Tesla has it everywhere. Multiple AI systems running in parallel at 99.999% uptime, backup batteries, fail-safes, so that no single failure can bring the aircraft down. This setup doesn't just meet the FAA's 1 in billion reliability standard, it beats it. Simulations estimate Tesla's approach could reduce crash risk to 1 in 10 billion flight hours. That would make flying in a Tesla plane safer than driving to the airport. The FAA has already approved smaller autonomous drones using similar systems, and Tesla is positioning itself as the next big leap. If regulators are already comfortable with drone automation, scaling up to Tesla's electric jet is the natural next step. Police car light quick reminder, if you're enjoying this deep dive and want to stay ahead of the future, hit that subscribe button right now so you don't miss the next big breakthrough. Now let's address something many people are still skeptical about. Can Tesla's AI actually handle emergencies better than human pilots? Here's a fact that might surprise you. Even the best pilots are human. A 2021 study from Aeronautical University found that fatigue alone causes 15 to 20% of aviation incidents. Think about it, pilots pulling long shifts, delays, weather issues, stress. Humans crack under pressure. But Tesla's AI? It never sleeps, never stresses, never loses focus. It processes 1,000 data points every single second: weather, altitude, thrust, turbulence. In emergencies, human pilots take 1 to 2 seconds to react. Tesla's AI reacts in milliseconds. When turbulence spikes at 30,000 feet, the AI instantly adjusts thrust and control surfaces, smoothing the ride before passengers even realize what happened. If an engine fails, Tesla's redundant neural networks immediately cross-check decisions, calculating glide paths and safe landing zones within seconds. And here's the backup plan that seals the deal: Tesla's human-in-the-loop design. If the AI hits an extreme situation, ground pilots connected through Starlink can take over instantly, like expert co-op players jumping into a video game, but in real life. This design covers 99% of emergency cases without onboard crew while keeping that vital human oversight regulators demand. The result? Up to 70% of crashes caused by human error could be prevented. Tesla's simulations show AI handles 100 times more variables simultaneously than human pilots, cutting emergency risk by 85%. And Tesla isn't hiding anything. Unlike black boxes that only reveal data after crashes, Tesla's AI keeps real-time logs explaining every decision: adjusted altitude by 1,000 foot due to detected 200 miles per hour wind shear. That level of transparency builds trust because regulators and passengers can see the logic, not just trust it blindly. This is why the 2026 Tesla super electric plane is not just another product announcement, it's a turning point. It's the iPhone moment for aviation. While Boeing is still patching old problems, Tesla is rewriting the future. So the big question is, will Boeing even survive this storm, or are we watching the birth of a new aviation era led by Tesla? Tell us in the comments, would you trust an AI to fly you across the country if it meant safer, cheaper, and cleaner flights? Type, "Tesla did it," if you believe this is the moment that changes everything. And if you don't want to miss what comes next, hit that subscribe button. The skies are about to change forever.